All right, let's wait a bit. Okay. All right. So let's do implicit differentiation. Um, and I'm eating some onion rings today. I had double whopper with cheese and no pickle. All right. So today we're going to look at implicit differentiation. So, a question like this. Um, Find dy dx if x plus y equals this. So when you get this type of equation with the two different variables, how do you find the derivative of that? So that's what we need to look at. So the way you have to read this, dy dx is take the derivative of y in respect to x. That's what we will look at. Now, when we do implicit differentiation, you have dx over dx also. And this means that take the derivative of x in respect to x. Well, this part is kind of redundant. Here's the reason why. Dx over dx is just 1. Whereas dy dx, it doesn't change. That's the variable, and this essentially will tell us what's y prime. All right. So how do we find dy dx of that problem? So let me give you the guideline. All right. Guidelines for implicit differentiation. Did I misspell it? Correct. No, I got it right. All right. So what's the guideline? And this is very important. Those of you who are going to take beyond calculus 1, you're going to see this over and over again. If you guys are engineers, you have to do multivariable calculus if you understand implicit differential, because you have to do in respect to different variables. So over here, first thing first, any question right now? Differentiate both sides of the equation with respect to x. Now, collect all terms involving dy dx on the left side. You could put it one side, it really doesn't matter. I'm just using a left side of the equation. And move all other terms to the right side of the equation. All right. Next, factor. This is algebra. dy dx out of the left side of the equation. And solve for dy dx. Did I give you pop quiz last class? I don't know if I'll give you pop quiz today or not. Let's see. All right. So we're going to use this concept right over here. This right over here. xy plus y 3. We're gonna find dy dx. Okay. All right. So let's look at it. Let's do the derivative of this. Right away, x y y 3. Right there, you have what? Product rule. So over here, you did x prime y plus x times y prime plus, and then we do y prime, and then 3 prime. All right. So what is x prime? X prime means, in this case, we're taking derivative in respect to x. So derivative of x would be just 1. So I'm doing derivative of x in respect to x times y, plus x times derivative of y would be just 1. So I'm taking derivative of y in respect to x, plus over here again 1, and I'm taking derivative of y in respect to x, and derivative of a constant is just 0. So, and I don't need to rewrite all this x part and the 1. I just get 1 plus x dy dx plus dy dx. Y'all see that? Next, x plus 1 dy dx, and I get negative y. So dy dx is what? Negative y over x plus 1. You can do that. And that essentially is the y prime, the big y prime. Any question right now? Am I going too fast? Okay, so my young-minded scholars, try this one. Find dy dx. All right, try this. You want them to do faster? All right. Are you guys all excited? You're all gonna get $1,400 stimulus check. Was it my last class? Someone said they want to buy frogs with the $1,400 as a pet. I wonder, what are you guys gonna do? All right, so let's look at it. So again, I'm doing 3x squared dx plus, it's minus 4y dy dx plus 1 times dy dx equals 0. So I get negative 4y plus 1 dy dx equal negative 3x squared. I don't need to rewrite this part again, dx over dx. All right, now this problem is super easy. Oh Lord. Negative 3x squared minus 4y plus 1. But I want the problem to look pretty, so I will rewrite it like this. Any question, kids? All right, let's try a little bit harder. Y cubed plus y squared minus 5y minus x squared equals negative 4. Find dy dx. And are you guys done? Who needs more time? Maybe I'll give you a quiz today. Who knows? All right, let's try it. All right, let's wait a bit. All right, let's try it. So 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x dx 0. From there, I get 2x 3y squared plus 2y minus 5 dy dx. Wow, this problem is so easy. I can't believe I give you all this time. I get 2x over 3y squared plus 2y minus 5. That was super easy. Now, are you going to get this type of question on the test? I highly doubt that. Let's use the color blue. All right, let's try this one. X cubed plus y cubed equal 8. Find dy dx and the second implicit differentiation. So I want you to try this one first, and then I'll teach you how to do this one. Then this. All right. All right, so let's look at this. First thing first, you get 3x squared plus 3y squared dy dx equals 0. So dy dx equal what? Negative 3x squared over 3y squared, and cancels out. You get negative x squared over y squared. So that's my dy dx, okay? Now we have to use this to find dy second derivative. So for that, we use quotient rule. So let's look at it. Negative 2x y squared plus, it's just negative x squared 2y dy dx, and this is y to the fourth. And that is your d. That's the second one. Now, we have some issue. The issue is this right over here. And we have fraction within fraction. So, but we know what's dy dx. Right over there. We know what's dy dx. So let me just substitute all that information in. Let's see what I get. Negative 2x y squared minus 2y x squared minus x squared over y squared over y to the fourth. We could simplify that. This becomes positive, goes away, so it becomes negative xy squared plus 2x to the fourth over y to the fourth. And this, we don't like it. Here's the reason why, because we have fraction within fraction. Let's do the common denominator. When we do that, we get negative 2x y to the third plus 2x to the fourth over y to the fourth. And we know this goes down. So negative 2x y to the third plus 2x to the fourth over y to the fifth. Whew, that was a hard problem. All right. Let's try another hard one. Question? No? All right, let's try this one. Find dy dx. All right, so this one is a little bit tricky because you have two product rule going on. So let's look at this first one. 2xy plus x squared dy dx. Here comes the second part. 2y dy dx x plus y squared 1 equals 0. Now let's simplify it. X squared plus 2y dy dx, and on the other side you get 2xy minus y squared. So dy dx equal negative 2xy minus y squared over x squared plus 2y. Or you could also rewrite the problem like this way. I just factor out the negative. Now let's do this implicit differentiation with trig functions. So you have 2 sine of theta cosine r equal 1. Find dr d theta. So you got to take the derivative in respect to theta. All right, let's try this. So let's look at this. So this one, again, product rule. So the first one is cosine of theta. So I'm taking derivative of theta in respect to theta. So I don't need to write that. Cosine of r plus 2 sine of theta. And I'm taking derivative of cosine, which is negative sine of r. And I'm taking derivative of r in respect to theta. So I write dr d theta equals 0. So I just get 2 sine of theta, sine of r, dr d theta equal 2 cosine of theta, cosine of r. Now dr d theta equals cosine of theta, cosine of r. I'm doing some basic algebra, not doing, like, for example, negative goes away by moving it on the other side, and I don't even have to show the division 2 over 2. Sine of theta and sine of r. Well, this is also another trig, which gives us cotangent of theta and cotangent of r. All right. All right, let's try this one. You have x times cosine of y equal 1. Evaluate the derivative at the given point. 2 pi over 3. So again, let's do the product rule. So I get 1 cosine of y plus x times negative sine of y dy dx equals 0. So I get cosine of y x sine of y dy dx equal cosine of y. So dy dx equal 1 over x cotangent of y. All right, now we just plug that point in. So I get 1 over 2 and cotangent of pi over 3. You could use the calculator, you could use the table. Pi over 3 is 60 degrees. So sine over use the table. 60 degree 0 1 1 square root of 3 over 2 and 1/2. It's the other way around, 1/2 over 3 over 2. So I just get, oh, that's easy. So I get 1/2 times 1 over square root of 3. Yeah. This is, I just did the calculation in my head. What is cotangent of pi over 3? That is something you learn it in your Math 127. All right, so let's do some derivative of natural log. Did we do the derivative of natural log? No, we have not. Why have I not done that? Okay. So derivative of natural log. Let's do some properties first. Of natural log. So natural log of 1 is 0. Natural log of a times b is natural log of a plus natural log of b. Natural log of a to the n is just n natural log of a. And the last one is natural log of a over b is natural log of a minus natural log of b. Okay? From that, we can find what's the derivative of natural log of derivative of natural log. First, the simple one is derivative of just natural log of x would be 1 over x, where x is greater than 0. And but we don't get just natural log of that. We'll get other stuff like derivative of natural log of u is 1 over u times u prime, where u is greater than 0. So let's look at an example problem. Natural log of 2x squared plus 1 equal y. So what's y prime? obviously you get 2x squared plus 1 times 2x squared plus 1 prime. And what is that prime? 2x squared plus 1, derivative of that is just 4x. So if I simplify it, this is what I get. All right, try this one. You could use quotient rule. So what's y prime? Okay, so here's another way of doing that problem. You could rewrite it to make your life so much easier. Now we could do the derivative of that. It's super easy. 1 over 2x times derivative of 2x, which is 2, minus again x plus 3, and the derivative inside is just 1. And once we simplify it, I just get 1 over x minus 1 over x plus 3. All right, all right, let's try this one. I see no questions right now, which are good. 1 plus e to the x over 1 minus e to the x. Find y prime. Okay. All right, let's look at it. I'm going to use the same technique. And I get e to the x plus 1 over 1 minus e to the x, So if I simplify it, I just get good. All right, let's try this one. Find dy dx for e to the xy plus x squared minus y squared 10. Try this one, kids. Okay, so let's look at it. Product rule right over here. E to the x, y, and then we do the derivative of that, plus 2x minus 2y dy dx equals 0. Over here you get e to the x, y, x, I'm sorry, first one is y plus x dy dx plus 2x. Do you guys see why this problem is a little bit tricky? And then I just distribute the y, e to the xy, x e to the xy, dy dx, plus 2x minus 2y, dy dx equals 0. And then I get x e to the xy minus 2y dy dx equal minus y e to the xy minus 2x. So therefore dy dx equals, I'm just going to factor out the negative to make my life easier. Or not easier, it makes the problem look nicer. All right, any question? All right, let's do the last one. After that, ask me your questions. So what's y prime? Okay, so we're going to expand it again. And I'm going to use one of the properties. Now this makes my life so much better. So if I do the derivative of that, is just 1/3 x minus 1. Derivative of that is still going to be negative 1/3 x plus 1. You could distribute the 3 in there. You can choose to. And that's it. All right. Any question? It's coming. Word problems are coming. We're going to spend 2 sections on doing your word problem. Next class, I'm definitely going to give you a pop quiz, guys. So be ready for it. Okay, so I see no question. I'm gonna stand by online. I'm gonna stop streaming. You could still send me a text